Hey everybody, in this video we're going to continue graphing 2x squared minus 4x minus 6 and find the y-intercept, x-intercepts, and any other point that's needed and actually put these things on a graph. Okay, so we already decided that it opens up. We found the axis of symmetry, x equals 1, and the vertex of 1, negative 8. So now I want to find the y-intercept. So the y-intercept, if you have a parabola, and I'll draw one facing up since ours faces up, is where it goes through the y-axis. So that would be right here, that point. And what's true about that point always is that it's 0, a number. So what we're going to do to find that is you're just going to plug in 0 for x and find that corresponding y, because we know x is always 0 at the y-intercept. So for this one, if I find my output, if I make my input 0, it'll be 2 times 0 squared minus 4 times 0 minus 6, and I end up just with negative 6. But your y-intercept is a coordinate, so it's the point 0, negative 6. So in general, if you're thinking of your quadratic graph as ax squared plus bx plus c, it's always going to be 0, c. So that gives you a little quick way to get there. Okay, so the x-intercepts. This is what I think can be the hardest for people. So your x-intercepts, I'm just going to draw a little picture, is where you have the parabola touch the x-axis. And there's 3 different possibilities. It could touch it twice, it could touch it once, or it could touch it never. It could be completely above the x-axis or below the x-axis. So it's possible to have 2 real x-intercepts, only one x-intercept where it's also the vertex, or none. It like never has an x-intercept, never goes to the x-axis. And this should sound familiar. These are your 3 results when, or like possible results when you do the quadratic formula. So there's 2 possibilities, but the first thing you're always going to do is set your equation equal to 0. You're always going to do that. So I'm going to think, all right, what would make 2x squared minus 4x minus 6 equals 0? Essentially saying the y value, or f of x, the output has to be 0, because that's the case with any x-intercept. We want to figure out what's the input such that the output is 0, because all these coordinates that I highlighted in green here, they're some x value, 0. The y value is 0 on all of these, except for this, in which when we solve, we'll get imaginary answers. So when we solve a quadratic equation, we'll get 2 imaginary answers. Those aren't on your number line, you can't graph them, and that's the case. So now we have 2 options to solve these. You can factor, which would be great if it's factorable, or something that always works is the quadratic formula. So that's why we practice factoring. That's why we practice the quadratic formula. Now it actually has an application where we need it in order to figure out the x-intercepts. I'm probably going to use this any other point needed, because we have plenty of points. We'll be able to graph this. I'm going to use the quadratic formula just because it's fresh in our minds. You can always check if it's factorable. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. So that's 4 plus or minus root 64. So this, see the discriminant here is 64, right? Positive 64. So that tells me I'm going to get 2 different real roots. So I know my graph's going to have 2 different real x-intercepts, that I'm actually going to go through the graph twice on the x-axis. So then I have 4 plus or minus 8 over 4, and I can actually get those numbers. So 4 plus 8 over 4, which is 12 over 4, or 3, and 4 minus 8, so negative 4 over 4, which is negative 1. So my x-intercepts, my final answer, is that I have the coordinates 3, 0, and negative 1, 0. So my x-intercepts are 3 and negative 1. And those were the values that solved this equation. In the past, we just practiced solving this equation. And now it's just a piece of this puzzle of graphing this quadratic. And you can see why we broke it up into 2 days, because it's a lot. Okay, so let's graph these things. So I have a graph on the next page, and the first thing I like to do is the vertex. So it says my vertex is at 1, negative 8. So that's right here. And I know it's opening up, so I'm going to label it underneath, and I know that's not going to get in the way. And I also like to draw the axis of symmetry. So I know whatever other points I graph, everything should be symmetrical about this line. If I have a point to the left of this line, there should be a point an equidistant to the right of this line. Okay. We found that we had a y-intercept of 0, negative 6. 0, negative 6. And honestly, that's going to be about as much as you need to get an idea of what the graph is, because I can use the symmetry, and I know that this point must be on there as well, of 2, negative 6, because I can mirror it across the line. And then I could graph the parabola, but we have more points. We have the x-intercepts we found as well. At 3, 0, so 1, 2, 3, 0, let me do those in black, and negative 1, 0, is that what it was? Yeah, you kind of want to ignore the y-axis now. You want to make sure this is symmetrical about the line of symmetry, which it totally is. So I just graph all of those points, the axis of symmetry, and you know you're doing something wrong, or something was wrong in your calculations if you're not seeing the symmetry, if it's not making the correct shape of a parabola. And then I draw the one branch, and it has this curve at the bottom, and I draw the next branch. And there is our graphed parabola showing all the critical values. So I'm also just going to label these x-intercepts of 3, 0, and negative 1, 0. You'll also be asked to identify the domain and range often in these problems. And like we said in the intro, the domain is always negative infinity to infinity. All x values are covered here. It goes infinitely left and infinitely to the right. Like there is a point, negative 1,000, comma, whatever negative 1,000 squared is. Now my range, my smallest y value is, so go from the bottom, you hit negative 8, and then you have y values forever going upwards. So my range is going to be negative 8 to infinity. It kind of looks like that 8 just rotated. But that's your range, your smallest y value to your largest y value. So here's your graph. And that's how you get these values every single time. You'll get the vertex the same way every time. You'll get the y-intercept the same way every time. The x-intercepts you can solve by factoring or do the quadratic formula. And we'll do more examples, because you should know the quadratic formula doesn't always result in answers that are integers. Sometimes you'll have to turn them into decimals and just graph your best approximation. Or sometimes you'll get imaginary and you'll realize, oh, there aren't any x-intercepts, because maybe your vertex is 3, negative 3, and it faces down. It's never going to go through the x-axis. That's possible as well. All right, stay tuned for more math in your future.